Hello, everyone. I hope you had a wonderful holiday season and have a good new year. So today we will, for the first time, go beyond the TROPOMI NO2 product, and we will look at the TROPOMI formaldehyde satellite retrieval. And we will try to make some synergy between formaldehyde and NO2. So for those of you who are familiar with atmospheric chemistry, the ratio between formaldehyde and NO2 has been used as an indicator of the sensitivity for ozone formation. So to start with, this block, we have been using it for the previous tutorials, and the highlighted text here, this line, this is a TXT file that contains all the URLs that link the TROPOMI NO2 level 2 files. And similarly, we can create a text file with the links to the formaldehyde level 2 data files. And this one was obtained again from the NASA GIS disk. And I have already saved those two files in my directory. And with the path of this TXT file, we can call exactly the same function, this one, to download the level 2 files for formaldehyde over the month of September for 2021. This should be one. So this will save all the formaldehyde level 2 files into my local disk. And I have already done that. It actually took quite a few hours. Here, this is the directory that contains all the formaldehyde level 2 files that I have downloaded. Each level 2 formaldehyde file is actually larger than NO2, but they are all saved in the same directory here. Then the next step is to oversample or regrade both NO2 and formaldehyde over the contiguous United States, which is defined here, over the month of September in 2021, defined here. So this is the function that we have been used many times in the previous tutorials to oversample NO2. Where the NO2 level 2 files are saved in a format like this. So you can see it's level 2 files from TROPOMI NO2. And with a very simple modification, we can do that for formaldehyde, as we already have the formaldehyde files downloaded. It should be, yeah, like this. And the file pattern of formaldehyde would be just replacing NO2 with HCHO. So if we go back to the pattern, it will look like this. And then we change the product from NO2 to HCHO and save that to a different level 3 object. Okay, that's it. So if I haven't run this. Okay, so it will load the level 2 data for this month into memory and then regrade into the Kaunas level 3 grid. So it will take a few minutes. So we are not going to wait for it here, as I have already done that. So yesterday I have oversampled both NO2 and formaldehyde to a grid of 0.01 degree. And I have saved those two objects into NetCDF files, we have a previous video on the saving of level 3 object into NetCDF. So for today, we will just load them, load those NO2 and formaldehyde level 3 data back into memory from the pre-saved file. Okay, so now we have recovered those oversampled maps for NO2 and for formaldehyde. And we can plot them together. So this is a 3-panel plot. In the first panel, we will plot the column amount, or tropospheric column to be exact, for NO2. And for the second panel, we will plot the total column amount for formaldehyde. And because the raw data are defined in a quite high resolution, it's a 0.01 degree grid, and we can reduce the size of the data by using this block reduce function to reduce the resolution from 0.01 degree to 1/4 degree. Okay, so here they are. We have the tropospheric column for NO2, and for formaldehyde is just the total column. Okay, and they look normal. So NO2 are concentrated near cities. So you see all the big cities in the NO2 map. And for formaldehyde, September, we still see a strong bio-generated signal. So you see the forest in the southeast. And for the third panel, we will leave to the ratio between formaldehyde and NO2. And another useful thing to check is the coverage for those two products. So instead of plot the column amount, we can plot the number of layers if it's non-samples. Oh, it shouldn't be 90. Let's do 50. Okay, so if it's 30, then that means in this month, on average, every day you have 1 layer of coverage. As you can see, in some places where it's usually cloudy or for whatever reason, the retrievals tend to fail, then you have less coverage. So that will be a useful thing to check about how many data points going into your level 3 map. Okay, and then let's go back and make the third panel as the ratio between formaldehyde and NO2, or this F and R ratio. Okay, so to do that, let's grab the column amount of NO2 from the NO2 level 3 object. And similarly, the formaldehyde vertical column density. To be extra cautious, I want to take the ratio only when there is enough coverage. So that means if for a pixel we have too few observations, then I don't want to take the ratio between those two because the observations could be very noisy. So that's why I saved those column amount fields, and I want to filter them based on the coverage. Let's just define a minimal coverage. Say it's 5. So if for a grid size, a grid cell, if there are less than 5 layers of level 2 data, then I don't want to use the column amount there. Make it same for the formaldehyde. Okay, then we can just take the ratio between those two over formaldehyde VCD over NO2T VCD. That will be the ratio. So to make the plotting easier, we can do a little bit of hacking. So let's make this as one field of the NO2 object. So this level 3 underline NO2, it's a level 3 object, but it's also just a dictionary in Python. So we can just assign a new field for that dictionary. Let's just call that FNR. Okay, hopefully it will run. Then we can use the same function, and more importantly, this block reduce function to plot the formaldehyde and NO2 ratio. So instead of plot the column amount, now we generated a new field in this NO2 object. So we just plot this FNR. Let's plot on the third panel. Oh, and this ratio is usually a much smaller number. Let's make the max to be 5. So it's a ratio, and therefore it does not have a unit, right? Because when we oversample formaldehyde and NO2, we use the same unit. They are both micromole per square meter. So that ratio is just a dimensionless number. See how it works. Okay, so there are 3 panels: the tropospheric column of NO2, the total column of formaldehyde, and the ratio between formaldehyde and NO2. So now you can see, start to see some interesting features. So the ratio is very low near the cities where you have a large amount of NO2 relative to formaldehyde. So that ratio would be a smaller number, and for many cases, smaller than 1, like Chicago, Toronto here, and Los Angeles. And in the more remote regions where you have a more formaldehyde or VOC, then this ratio will be higher, and the ozone formation regime is more likely NOx limited. Well, I won't go to the chemistry here, and actually there are some debates on the accuracy of this ratio. But for this tutorial, we will just use this very simple ratio as a kind of qualitative indicator and as an opportunity to introduce a more flexible usage of the physical oversampling code. And one final thing I want to note here is that, okay, here we averaged 2 data for a month and formaldehyde data for a month, and then take the ratio between those 2 monthly averaged maps. But another way, actually, you can totally do a daily ratio, right? So you calculate the map of NO2 as well as the map of formaldehyde every day, and then take that ratio for that day. And then instead of oversampling NO2 and formaldehyde separately, you oversample that ratio. So I have never done that, and by itself, it might be one interesting feature to check. And actually, it's very easy using this framework. So instead of oversampling over this monthly interval, you use a loop over each day for that month, and then use the merge function to merge the level 3 object. So something to try out if you are interested. And I'm also interested in the results. If anyone in the audience can kindly share that with me. Okay, so that's it for today. Thanks very much.